Alright, question number 5. So question 5 is talking about gravitational force. So there's only one equation for gravitational force, which we'll get to in a second. So the first thing is to fill out all the variables. So you're trying to find the gravitational force between an electron. To find the mass of the electron and the mass of the proton, which is given to you in the problem, so you can plug that in. And then it also tells you what the value for force is in that case, so we can plug it in too. Capital G is a constant, so 6.673 times 10 to the negative 11th is always the value for capital G when we're solving problems like this. And then the problem does give you the value for force, as I mentioned, of 1 times 10 to the negative 47th. So this formula misses the radius in terms of what we're already given. So the formula for gravitational force is capital G, m1, m2 over r squared, where G is the constant, m1 and m2 are the masses, and radius squared is the distance between them. Now this formula is called Newton's law of universal gravitation, and we can use this equation for any objects, planets, anything if you want to. Now most of the time for Earth we just use mass times gravity because we already know that little g is constant on Earth, but when we're talking about bigger objects we can use this relationship. And so Fg in this case is the force of attraction between the objects in question, where m1 and m2 are the objects. And then again, r is the distance between them, and it usually goes from center to center. So if you're talking about planets, you usually have to include the radius of them to calculate, but not all the time. But that's usually how you're supposed to go about doing the problem. Right, so then in this case, based on this formula, the only thing that we're actually missing is the radius. So that means we can take this equation, gm1 m2 over r squared, plug in everything that we know, and solve for radius. So it's 1 times 10 to the negative 47th equal to the constant g times mass of electron times mass of proton divided by radius squared. So you go through the process of multiplying, you end up getting radius squared equal to 1.015 times 10 to the negative 20th, which you can then solve for r to get 1.007 times 10 to the negative 10. So it's a very small distance apart, but again that makes sense because the force is teeny tiny and we're talking about two very small objects. So a radius that size is logical.